All right. For the final examples of today, the parent function f of x is equal to x squared. We've graphed rational functions. So I have highlighted y is equal to f of x is equal to 1 over x in red. Choose important points or ideas from your parent functions to locate the image points. So we need to help determine the image points from major ideas or characteristics of the function. We're going to determine the equation of the translated function in the form y is equal to f x minus h plus k. Now, I'm going to help us out along here. Here's the red graph. Here's the green graph. I'm going to ask myself, how do I change the red graph into the green? And by the way, I can only shift this left, right, up, down. You may be asking yourself, well, why can't I do other things? Well, because that's not what this lesson's about. I'm going to identify the characteristics of rational functions, and that are the asymptotes. There we see one asymptote right there. And we see another asymptote of my parent function I'm talking about right here. So my horizontal asymptote really is y is equal to 0, and my vertical asymptote is x is equal to 0. I go take a look at the green, and the green function looks something like this. It looks like I have a vertical asymptote at x is equal to 3, and a horizontal asymptote, now they have to be dotted lines with arrows, y is equal to 2. And once you have the equation of the asymptotes, or even just drawn them, you see that the intersection, it's kind of an important point here. The intersection moves from 0, 0 all the way to 3, 2. So I think that h, it's safe to say that we move this 3 units to the right, and that we move 2 units up. 3 units right, 2 units up. There we have it. So how do I do that? Well, I start off with y is equal to f of x, and if I'm going to write that with h and k, it would be y is equal to f. Now I'm going to put that h in there, x minus 3, so that would symbolize a shift 3 units to the right, and then I add 2. So that is the transform function in the form y is equal to f open bracket x minus h plus k form. And in the more standard form, it would be y is equal to 1 over x minus 3 plus 2. The h is always attached to the x in brackets. Try to make note of that. If I were you, I'd probably write that in your notes. All right, moving on. We need to choose important points or ideas from my parent function to find the image point. So I need to determine the equation of the translated function in the form y is equal to f of x y is equal to f open brackets x minus h plus k. I guess I need to define what is my parent function. Let's start off by just saying, hey, let's just let this one up here being my parent function here. It's a really weird function. It is what is known as a piecewise function. It's just broken up into different pieces, but nonetheless, it's a function. Now, how does y is equal to f of x change so that it becomes y is equal to f x minus h plus k? So first off, I'm going to look at important points. Like this point way up here, and I'm just going to arbitrarily call this point B, looks like it's going to be fairly important. So it moves to B primed. And just for fun, I'm just going to take maybe this, I'm going to call this point A, and it's going to move to A primed. Well, how did point B, which is the top of the mountain, move to the top of the mountain? Well, B looks like it moved 3 units to the right and 1 unit down. So 3 units right, 1 unit down. Now, if I do this with A and A primed, well, A moves 1, 2, 3 units to the right, 1 unit down. So that's consistent, and that's what we know. So 3 units to the right, H is equal to 3. 1 unit down, K is equal to -1. So although we started off with y is equal to f of x, the transformed function has the equation y is equal to f x minus 3 minus 1.